thing about LLMs is they are trained to give you an answer no matter what, even if it's false. The rate of reliability and accuracy when you add an ontology is as high as 89% accuracy, which is high relative to AI.
Hi, Jessica. Thank you very much for joining my podcast.
Thanks for inviting me. I'm really excited to be here.
Yeah, I follow your Substack and all of your writings around the new hot topic, ontology. I work with a lot of financial services customers, but I also talk to other practitioners in the field through my community and the work that I do in social media. Ontology has picked up a lot of discussions, but a lot of people don't have enough knowledge on it, right? Because we have not been doing it for a long time, right? So I think you are the perfect person to tell us why ontology, what it is, and how we can implement it, let's say, right? Or how it plays out in a production scale, large enterprise kind of setup, right? This is what we're going to cover. I think before we start, I would love you to tell my audience about yourself, your background, and why should we listen to you when we talk about ontology.
Oof, that's a tall order. So my name is Jessica Talisman. I live in Santa Cruz, California, so the Bay Area, San Jose area. I've been practicing I've been a practitioner since 1997. I come from a library science background, but I also have a history degree and I also have a master's in teaching. So I sort of combine those superpowers, have combined them throughout my career. So I've worked as an academic librarian in the past, but I've also worked for enterprises and cultural institutions. I can tell you, why should you listen to me? I have run the gamut in terms of domains and areas of practice. And what's so interesting is consistently throughout my career and in almost every single instance, whether it be a library, a museum, a collection, an enterprise, the government, the same problems remain. And that has to do with knowledge. It has to do with the organization and management of knowledge. And that's what ontologies do. So when you can transform an organization, and it's not easy, no matter what type of organization, from sort of a messy reality into a more dimensional knowledge-driven organization, you alleviate a lot of the pain points and issues that exist in terms of findability, discovery of assets, and with AI now, the implementation of knowledge management infrastructures are critical for reliable AI. And so one of the reasons ontology is so hot is it's a form of symbolic AI, and a lot of people don't realize that.
What are the benefits? Why should I invest in learning about ontology today?
It's not easy to learn about ontology because it's a different practice, but most of all because, and I'm going to sort of pull back the conversation just to give a comparison, because most of us are used to working in relational databases, which follows relational logic. Relational databases also assume a closed world reality, which means that if something doesn't exist in the database, then it's false. It's assumed to be false. And that's practical and it's needed for managing data at scale. The difference is that with ontologies generally operate according to an open world assumption, which means if it doesn't exist, it's unknown. And knowledge itself is constantly expanding and contracting. So we have to be prepared, especially with AI, to be prepared to review, accept, encode, and consider the unknown. So that means that we need to manage our knowledge. Knowledge exists outside of the confines of just a database as well. And we tend to forget that. We have knowledge that lives and exists in text, in content, in our SharePoints, in these sort of textured environments. And there has to be a way to synthesize all those things. And that's what ontology helps us do, is not only to represent the data, but represent the classes or declare and describe the things that exist in our ecosystems in a semantic, interoperable way.
Okay, and so what I'm thinking is, if I'm talking to an exec, right, in an organization, a leader, let's say, who has got this job of AI transformation, right, and they're saying, hey, we're hearing about ontology. What is this, and why should I spend time in investing in it? Is it going to give us any cost benefit? Is it going to give us any accuracy benefit? What is what is that one thing or two or three things that you think ontology brings to the table that I should really focus on it?
So descriptive logic is one of the things. So if we're constantly using our data, even our semantic layers that represent our tables and our metrics, you're only giving a fraction of the picture, but you're also losing the descriptive logic that you introduce to machines. So as it pertains to AI, the form of AI that we are currently working with is called generative AI, which is statistical and probabilistic, predicting the next token. So that is not enough for reliable AI. So when we receive models on our doorstep, these commercial frontier models, they already have training data, and that is a black box. That's called the parametric layer. So for leaders, there needs to be reliable, semantic, machine readable, and interoperable, repeatable descriptions of not just our data, but including the content. We have to be able to describe and explain our business logic, our business rules to machines, the things we care about. So that is probably one of the most important things, is that you're giving machines with an ontology symbolic reasoning. Symbolic reasoning means that you're representing things in a triple format. So that encoding structure, which is the syntax, structures statements that are called triples, that just like a sentence, how we learn language, is subject, object, predicate. So we move beyond the probabilistic and move into the descriptive that actually explains for machines, this is what we have, and this is the definition of what we have. And this is what our business cares about. You can actually encode that. So once an ontology exists, that can help to drive in repeatable patterns a sort of master data view of a domain or a segment or your entire business. And it also helps with the discovery of new concepts. So businesses are always changing and evolving, and when you start to implement ontology, you're able to discover new terms that enter the site, new concepts, new entities that the business cares about. So you're able to evolve that reality that represents what your business cares about. So it's sort of like, I think of it like a digital thumbprint for your business, right? You're getting out of the straight, it's boutique and nuance that describes exactly your business versus cookie cutter, right? And if you just take what is out of the box, then you're basically accepting that your business is like everyone else's business. You need to tell AI, the generative AI, that these are the things I care about. Now, the third thing is there's a domain of study. It's not new. It's called Neurosymbolic AI, and it is the synthesis and combination of generative AI with symbolic AI. Generative AI is neural. So when you combine the two, the symbolic counterbalances the predictive statistical model and is able to very directly guide an LLM to continue to sort of stay on course, and sort of an instruction set, if you want to think about it that way, in terms of like guardrails of how to create boundaries around data, and to be able to sort of curate and define. And that's just something that is missing from data only approaches. Even semantic layers, that's the big problem. A label is not enough.
Let's break it down a bit, right?
Okay.
When
Yes.
we talk about ontology. So first, let's put a comparative analysis first, and then we'll get into the structural. So what I mean by that is, a lot of us understand what is a database.
Mm-hmm.
We understand what is a data lake, what is a data warehouse. We kind of understand, okay, there's a data catalog in play. We understand data catalog.
Those are storage.
Correct. So
Yes.
all of these have had their own era, if you like there was database era, then data lake, data warehouse, data lake, and catalog. Like, you have always seen the war of the catalogs the last few years, right? Where does ontology sit? Is it comparable to these concepts, or is it something totally different?
Totally different.
Yeah.
Now, coming from the library science space, library science catalogs are often have an ontology backbone, right? So stretch it outside of what you see as a catalog with just the fields and the labels. Each of those fields could be part of an ontology. But relational databases, when we look at lakes and we look at warehouses, you have to go, and we cannot extract or just divorce ourselves from the reality that SQL and relational databases and warehouses and lakes were designed for big data. Okay. And big data is about storage and query. And so it differentiates because we move beyond the storage and query to creating dynamic relationships between things that it may exist and may not exist in our database. So when you get into that description, what you often see, and this is like just breaking it down, is we'll create these like complex queries and joins and bring that into production. So it's drawing upon the storage. We're reliant on primary keys and foreign keys. Some queries can get very brittle because you're trying to force the data to behave in a way, to synthesize in a way that is pushing the bounds of what it was designed to do. When we move into ontologies, we don't have primary keys and foreign keys. We do have logic and rules, but it's more about forms. And that's what's most important. We're not just describing data, but we're describing our realities that may have relationship types that extend outside of what we can support in a storage form.
And are these expressed in graphs?
So yeah, so an ontology, and I'm kind of a stickler about this, is we hear knowledge graphs and people just assume it's knowledge graphs are all the same. But in fact, I see knowledge graphs as an architecture because there's so many decisions. You can include a vector database, you can include NLP, you're going to have indexing, you're going to have all these different things that are going to be part of your knowledge graph. An ontology is one of the core elements of a knowledge. That is the rule base. That's what helps to support inference and reasoning, your ontology, because you can declare that two things have a relationship, but you can also declare boundaries on relationships. Like this can only be a one-to-one, similar as in a database, but then you can do more in terms of saying these things cannot have relationships, right? So it goes both ways in terms of your flexibility and relationship types. You don't just have join, you have disjointedness, you have restrictions that you can place. You can have declared format types accepted, like only literal or integer, or, whatever the data entry. You can create ranges in terms of what data, format and range is accepted for a certain property or class. So those types of things, if you think about it, and you're stitching together this reality that does not have you're not subject to the rules of relational logic. It's about descriptive and abstract logic. Those are two different functions.
So let's look at the structural piece, right? So
Okay.
what I'm thinking is, what is it made of, right? So you have described some of these, the triplets,
Triples. Mm-hmm.
triplets, and the concept that let's take an example, right?
Okay.
And the example could be a question that I pose to an AI agent, right? And how would that then take advantage of an ontology to answer those kind of questions? Maybe that, or something, an example that comes to your mind to bring it more to life.
Okay. Where do you work?
I work in Databricks.
Okay. And what's your role?
So I work as a technical lead for data and AI. So I basically work with financial services organizations, running some technical projects for them where they implement data platforms and AI use cases and stuff like that.
Yeah. So if I were to model you and your reality, is you're an agent, usually with ontologies. So on the back end, it's like I've declared you're an agent, and that agent is a person. That's the subclass, is you are a person. That's kind of immutable. I can't take that away from you. I mean, I'm looking at you right now and you're definitely a person. And then you have the data. And right now you're employed by Databricks, right? And think of that in terms of like a property. It's a way of describing. So you are an employee. So that is a property of you as a person. If you all of a sudden are not an employee anymore, the person will continue to exist regardless of your state, right? You can change elements about the person, these attributes about you. And that's what's really important. So if I'm managing an ontology and I'm managing your status within Databricks, for example, and who you work with and the accounts you hold, that is going to create constraints. So with an LLM, if I need to find everyone at Databricks that works with financial services and AI, those constraints and those rules, if I say, okay, we can pull up everyone who is at this level and above, or, that there's some sort of rule or constraint, I can guide that query so that AI has those guardrails and understanding. And when it can't find an answer, it's not going to hallucinate, right? That's one of the biggest, because that's the thing about LLMs is they are trained to give you an answer no matter what, even if it's false. So, and ontology is going to help to guide, and that's where you can give instructions that says, like, if it's not in the graph, if it's not in the ontology, the answer is I don't know, or you have it like the unknowns go into sort of a work stream that then becomes material from which you say, we don't have representation for these things in our ontology. And then you have a natural workflow of expanding your ontology or refining your ontology to make sure that you are including that authoritative fact-based information in your ontology. It becomes like this work loop, the cycle.
Okay. So it's almost like a map, right?
Yes, it's like a map, and
navigation.
yes, and it's a map and a compass. That's the coolest thing.
Right. Yeah.
Rules of an ontology become your compass, and the map are all things within your organization.
Which also means that when implemented at scale, there will be cost benefits because your queries are not like lost. Like they
Right.
take the one path, the shortest path.
Yeah, and if you look, there's incredible research. It doesn't need to be that complex of an ontology. You know, the rate of reliability and accuracy when you add an ontology is as high as 89% accuracy, which is high relative to AI. And I've seen studies that actually, peer-reviewed studies that actually point to even greater benefits. And even with something as simple as a taxonomy, eBay has a great study out with just, refining and implementing an RDF ontology, meaning encoded like the semantic web style. They were able to drive reliability to just an insane scale. So that's the ideal. And when it's not reliable, best practices are that's like a very essential human in the loop element.
Okay. How is it different from context graph?
Oh gosh, context graph. Context graph has not been defined as strictly RDF. So you see this wild range of context graphs. Some of them are just bubbles on a page with lines between, but not the ontological coding structure behind or logic. So you see some things like Carthy's Wiki LLM with Obsidian. That could be seen as a context graph. There's nothing holding it back from saying this is a context graph. You have property graphs can be a context graph. RDF graphs can be a context graph. So when you have nothing that defines it within the bounds of like, this is symbolic AI versus, right? You can't really define it in a way that you have this reliable, repeatable architectural pattern. It's just a concept in space. Like you're just a context in a graph, whatever that means to you.
Makes sense. Yeah, that's what I was about to say. Like, is any context, if you can put it to a graph, like in a graph model.
What's context?
Yeah, I was listening to a podcast, and what I understood it is not only about what's defined today, but as agents run and they discover new stuff as things are happening in the organization.
Yeah.
They also can model those contexts in a relationship.
Yeah, I mean, you would have to trust. I mean, it's like, are you favoring the LLM's version of your business and your reality? I mean, like, for example, I had an LLM. I set up a workflow with Claude to organize my 14,000 plus screenshots into folders and label them. I gave some boundaries and some understanding, and I had synonymous terms like folders where it's like, no, that's not right. When you look at something that comes, an LLM categorization and relationship type, I had folders and subfolders, and it wasn't quite there. It didn't describe, and some of the concepts were overlapping. Right. So some screenshots were about knowledge graphs. Some screenshots were about knowledge organization, but most of the screenshots, that categorization was not right. It depends on your business. If you're moving so fast that you don't care and you'll just take the LLM's version of what it thinks your business, the things, the tasks, what we're calling tasks and knowledge is within a system, all the more power. But I think it's one of the things that needs to be cared for and really shaped, because we are presenting literally, this is what you care about. This is your business model. This is your business logic. If you're asking the LLM to create your business logic, that would you have LLM create your security plan or your governance model? I guess it depends on how you roll, if that's acceptable to your business.
I think there are some good amount of years before that happens. You mentioned RDF. That term gets thrown around a lot in these kind of discussions.
Yes.
Can you expand on that a bit and kind of explain what it is and
Yeah,
what are the other formats
sure.
and
So, yeah.
what it helps with basically?
So RDF is a W3C standard. And so there's this whole governance model for ontologies and ontological structure and data models that's governed by the World Wide Web Consortium, right? And the thing about RDF and a thing about ontologies and W3C ontologies is they're open and there's no vendor lock-in. You could build a knowledge graph environment for little money because you can just set up your own database, your own indexing, your own Sparkle query endpoint. You can build that all without any sort of vendor dependence, which is great. RDF is just RDF is the data model. That is the data model that helps to encode. It's really a serialization format for ontologies. So that is what is structured. Resource descriptive framework, which is the data model, structures statements in a format that we call turtle. That's RDF. And turtle format is subject, object, predicate. So that is, Sandi is an employee of Databricks, right? And that is a simple RDF statement. So that there's some logic and there's the transitive and the direct and indirect, and there's, the rules that are part of that. And then we have another standard called RDFS, and that's the schema. That's a very small vocabulary that's used to express the data model. So a lot of people don't realize like the core to ontologies is really data modeling, if we were to translate it. And that data modeling is really centered on descriptive logic. Like, how do I describe these things logically?
Okay.
I'm not naming tables, right? I'm not naming tables, columns, and rows. That's not the modeling exercise. The modeling exercise is, what is my reality?
Okay. And that means concepts like I work in Databricks, I'm in this department. Is that how it expresses?
Yep. And what's really, there's different formats, so how I would write, you can write these RDF statements, and that's called turtle, but it can also be in JSON. You can download, the formats can be JSON, RDF XML, quads, trip, straight up turtle format. You have trig, you have all of these formats. Now, the really interesting thing is, no matter what, as long as it all has that RDF data model, no matter the coding structure, the syntax, they're interoperable. RDF is that interoperability layer. It allows graphs of different syntaxes to exchange information and even to communicate with one another. Again, I will remind everyone, once it starts to sit with people that, oh, this is a form of AI, and there's not just this one form of AI, meaning generative. When we say AI, we're throwing it around. There's neurosymbolic AI, there's symbolic AI, there's these other forms. And the fact that we're all using just this probabilistic statistical predictive model does not scale. So it's like, how do I add context? Context is the right idea, but context is broad. It could be a paragraph from a document, and it could be like a link to a Wikipedia page. It could be, anyone's context. So how do I describe the context?
Makes sense. I think we are already treading into the how territory. So I will ask the how question.
Yeah.
So you already mentioned RDFs can be expressed in different formats, right?
Mm-hmm.
Tell me, like, so let's say that I am someone who wants to build ontologies,
Mm-hmm.
right? Or I don't know even build ontologies is the right term or not, right? So where do I start? How do I scope out projects? How do I assign resources? Like, what does it look like? To build this?
Yeah. So one thing I'm going to say is, like, the biggest mistake an organization can make is you need to have a plan, right? So you need to have strategy around it. It's interesting because the first is education and upskilling. So I co-teach and lead with Katerina Kari and Tony Seal. We started Knowledge Graph Academy, and this is not necessarily a plug. There's other programs out there. The idea is that you can't assume the skills are in place, because this is a different type of skill set. Services. I first, presented at their Unlimited, their internal conference, with one of their VPs. People need to understand that there's that base education of, just like we discussed, what are ontologies? Why is this important? Where do we start? And I am a big proponent, for example, of, I have developed that framework Ontology pipeline, specifically because the first stage to modeling ontologies is to first develop a taxonomy, a hierarchy, and create that taxonomy in RDF. We call that the C box or the category box. So it's not technically an ontology, but it is in that RDF format. And that helps to introduce people to learn, for example, how to write these RDF statements. What is the RDF model? What does our concept model look like? How do we define these things? So everything that everyone's doing with semantic layer, it's that same kind of exercise, but transposed into the taxonomy exercise and creating an RDF model. It's number one. And then once people get their hands dirty and understand how to model these SKOS, which is Simple Knowledge Organization System, it's a specific RDF data model for taxonomies, then you are able to get people accustomed to and used to writing an RDF, the code structure. How do we leverage this? How do we use it to help search and discovery? Taxonomies, RDF taxonomies do a lot of heavy lifting in terms of like driving AI reliability. In a lot of cases, all you need is an RDF taxonomy to help to guide some reliability and to create those boundaries. See how it performs, see how it helps your organization. And then that naturally evolves into the next level because you're going to want to mature that model and stretch outside of a hierarchy. And what that means is a hierarchy taxonomy can only support parent-child relations. That's it. When you want to stretch outside of that box of parent-child relations, like, that a concept can have a collection of children, that in itself can help provide inference for a machine. Then you want to create relationships outside of that parent-child relation that I want to say something like you're an employee of or you're a person. That's when I need an ontology. And so then it naturally starts to evolve and it becomes an active learning cycle for an organization. But again, it has to be founded on strategy. And it's not necessarily as fast as build fast and break. That's the other thing to accept. Like, this is a muscle that your organization is going to have to build. And it does not necessarily fit into your normal cycles, your normal data engineering cycles. It's going to have elements that are maybe fall into a different cadence. And we're seeing this at scale that jobs, roles, and workflows are changing. So if you're building the organization of your brain, it's not going to be like a flat, it's a dimensional activity.
And so, like, if I wanted to draw parallels to something that we already understand, like taxonomy is basically like you need to do like a modeling exercise, right? So to understand the
conceptual
business
modeling.
Yeah.
Yes.
And who does that in an organization? So when you work with, let's say, Vanguard, right? Who is responsible from their side to pick these kind of projects up?
Well, that's what I'm saying is like, Vanguard in this case, I'm doing a lot to teach as we're doing. So I like to call it active or collaborative consulting. I'm not coming in there and serving anyone room service because right now, who's going to do it? If you don't have the skills on the ground and people that are trained and understand the descriptive logic, for example, are you going to hire someone to build your data warehouse who has never really touched a data warehouse? Just a question. Would you do that? Would you allow someone to just architect it and build it, design it, architect? Right. So the same goes for ontologies. The assumption that it's called epistemic squatting or trespassing, is that if someone's an expert in data warehouses, then they are automatically experts in building ontologies. Not the case. You need to build the skills. This is all about knowledge and skills. You have to learn about how to model the conceptual modeling version for RDF, which means you have to understand the RDF logic and data model. So when I go in, I'm not just building and handing it over on a platter. I'm building the skills. I'm doing little trainings. I'm helping them to understand how we model things. I'm looking at the databases and figuring out how are we going to bridge these gaps? What are we going to use as a reference architecture between these two systems, between your symbolic system and your relational system, your database system?
Is there any tool that you can automate this with?
Yeah, everyone goes straight to automation. And I want to go here just briefly. Is traditionally in AI, before these foundational model, commercial models were available, there is sort of like an ethos with AI that you augment before automate, augmentation before automation. That's the natural life cycle. because you first have to make sure that it's aligning with the quality of human tasks. But if you go from 0 to 60 and are like, I'm just going to automate this and trust a machine to do it for me, I don't think that's going to work out so well. You have to understand. And one of the biggest reasons is if you do not understand RDF, how are you going to debug it? How are you going to manage it if something goes wrong? Right? It's like if you were to deploy a system in French and you don't speak French, and that's, you own that system. How are you going to manage that system when something goes wrong, or the translation's wrong, or the representation's wrong? So it's sort of like a two-prong answer to that one. But then on top of it, when we move, once you have your framework, your ontological framework, you've declared, I'm using the RDF data model, I'm using the RDFS schema, that's just a given. I'm going to use a little bit of OWL-DL. I'm going to use some schema.org. I'm going to build my own little ontology, because like you can combine different ontologies to build your system. So the other part is when we get to that stage where you have this ontological core framework and you've already declared some rules in the shape of what you're modeling, that's when Neurosymbolic AI comes in. And that's where you can use an LLM as a partner to help to expand your ontology and help grow and build your ontology. So I would say augmentation first before automation. Once you have a reliable pattern set up, you can mature into automation. But out of the gate, that you need to have the human muscle.
Makes sense. You're talking about like, so it clearly is clear that it needs education and skill building. So you're training some people. So again, when you go to these organizations, who are the people who they will spend on for learning this? Are these the like the people in data team or in the business team?
That's an interesting question. Both.
Okay.
Those lines are getting blurred now, right? Even a business team is technical, and the
But
technical.
what I'm thinking is not everyone needs to learn how to build an ontology, right? So
No. You got to find your shining stars and the people that really grab onto it. You know, for example, someone, you know, the people that express the interest and invest the time to learn, maybe even outside of the hours of your day, are obviously the ones that are going to accelerate and provide value beyond the immediate description of your role, right? So as skills change, is this something you want to do? That's one question. And the second is like we provide through Knowledge Graph Guys internal embedded trainings that are customized for organizations. So a lot of times the people that express interest are coming from across different teams, and they specifically have been appointed or selected to be the ones to model. I can't say that there's an IQ test for this, but there's definitely the ones that want to lead out. I will tell you that sort of relational data modeling tends towards system one thinking, right? You're just immediately saying, this is in front of me. And it's things that are most obvious that present themselves in the database, and you don't care about things outside of the database necessarily. But with ontologies, that's a slower type of thinking because you're modeling forms. It's different. You're not modeling just instances. You're modeling the forms, the things that define the instances.
So if someone, and do you see like people who learn about it, like do they need any prereq skills or experience maybe in modeling, or anyone can do it?
Abstract thinking and logic is necessary. So if you've ever taken standardized tests like the SATs, or, you know, LSATs have a lot of abstract logic in it. It's just a different way of thinking, and it just depends. I've had content management folks and strategists that are rock stars at modeling this type of thing because they understand the shape of content of technical writing. Those people tend to do well. I have data engineers that have created dynamic, amazing systems because they understand sort of reference architectures, right? And they know how to translate things, but keep the dimensional shape of an ontology without, you know, flattening it. Those people tend to be rock stars. You have to be a systems thinker no matter what. So it's hard to say that there's one type of person, but you definitely have to take an interest and you have to be committed.
Okay.
Yeah.
That makes sense. So if let's think of a context of a big organization, right? Let's say with multiple, large organization, financial services like Vanguard, right? Beyond the skills, like and education and training. So when they move forward, right?
Yes.
So how
and
would
you asked me about tools.
Yep.
And I think that's what's important is for large enterprises, there are semantic modeling tools. We call them semantic middleware. they're called semantic, and we always have had the semantic layer because the semantic web, and that's what
Yeah.
ontologies were born out of, and we tend to lose that context, and it's important. And so these semantic middleware tools are built with reasoners included, lots of API endpoints for data portability, no vendor lock-in on your code. Tools like Top Quadrant, Stardog, GraphWise, Metafax, they are tools built to help you model your taxonomies and your ontologies, connecting data, creating and building APIs, queryability, writing shackle constraints, building shackle and Sparkle libraries. So for an organization, you're going to want to have those tools in place because it allows you to build to scale at enterprise scale.
Yeah. And so if I had to build in my organization, is there a, how do you scope it? Like, I'm sure that you have to start small somewhere.
Yeah.
Like, is it working backwards from a customer journey or use case, like typical, like how we do data projects, right? Or is it more about something else?
Yeah. So what we do is, for example, you'll have one area of business. It's usually selected or determined as like a domain, right? So we would have like a certain product type. Let's just say that. And from that point, you're creating that conceptual model of that part of the organization. In terms of scoping, the first thing we do before creating the concept model is we go through an exercise called competency questions. Competency questions stay with you throughout the entire ontology design process and workflow. So competency questions could be a collection of 5 to 10 questions that you want your model, your ontology, to answer when you've launched and you've built, created, and launched it. What's beautiful about that is you're building for purpose. You're conceptual modeling, so the building of your taxonomy, you're declaring the things that matter for your domain. You have to think about what is the end goal, like anything else. And the end goal is you want it to drive certain accuracy and to actually render results or answers to certain questions. That's should be the same for databases. So as you design and build, you have a testing framework throughout the process where you transform your competency questions into queries. You can query an ontology, you can query a knowledge graph. When you query a knowledge graph, you're querying the ontology. So you test your Sparkle queries throughout. You have achieved success when your ontology can answer all the questions that you set out to design or to build, to answer. Those can be part of an eval structure, those same competency questions. So a competency question might be like, tell me all employees at Databricks that work with financial services and also have competency in building AI AI optimized ontologies. I mean, you can have a high level of specificity. So if you know you need to answer a question like that and have it be completely accurate and render results, then you're helping to drive from principles, like organizing principles. You're helping to build that essential, only what matters for that specific MVP or POC. And then you can always expand and you can always build further. But after you successfully launch, you're going to probably come up with more competency questions that are going to expand into new use cases. So some people call use cases competency questions within the ontology modeling world, but use cases have to be supported with like, what questions does this use case need to answer?
Okay, that makes sense. That's almost similar to how we are doing data and AI projects as well, right? So there is some similarity that I found in this approach. I think so. You touched on, like, you talked about databases, indexes, SparkQL queries, and things like that. Let's lay out the system architecture for this. How does it actually look like, right?
I wrote like a whole 3-part series on this, and it really, it's very complex. Like, how does it look? Well, everyone's going to have, some people build ontologies without taxonomies. I don't recommend it because I see taxonomy and language, which is what a SCOS taxonomy gives, is that interoperability layer with the business, much like semantic layers serve, the metrics and the definitions. Right? It's very similar. So normally, I think you have a knowledge base. This is how I would architect it. It really depends on the system and the use case, though.
Yeah.
So you'd have a knowledge base. You might have NLP, like a little bit of NLP. You're going to have your taxonomy, your SCOS taxonomy, And then your ontology, which has the terminology box, which are the classes, which are the T box, and the A box. And the A box is your assertions or your data, how you represent your data. You're going to have obviously API, right? Depending on, you might have a vector database as part of it. You might have clustering as part of it. There's sort of this like, what's going to help to leverage. You're going to have indexing for a graph, right? Because how are you going to search it? You're going to have your Sparkle endpoint, which is how you can query the graph. You are going to have your shackle, which is going to be your shape constraint language that can help to drive accurate queries or to help to validate your graph. You're going to have your, possibly, not everyone has a reasoner. There's a number of different reasoners you can shop from. They're all open and readily available, but that's how are the queries driven by the logic of my ontology. So you might have a reasoner as well. There are so many nuanced decisions that go into architecting a knowledge graph, and people lean into knowledge graph right away. But you first have to, and often most enterprises, especially for AI implementations, may only need an ontology, a taxonomy and an ontology. That may be enough. But if people want to go full board and build this sort of ecosystem that includes all these different elements, you have to make sure you're making sound architectural decisions. Do you really need NLP? Do you need a vector database? Is the ontology strong enough and the search index and the reason are strong enough that you don't need a vector database? Do you need a data cleaning, methodology for data cleaning, like some sort of cluster analysis before things are, quasi-automated to be considered, for ontological inclusion, if you're using an LLM to help to refine and expand your ontology? There's so many nuanced decisions that go into our
Where do you actually store this? Like, do you store ontology in a database?
graph databases.
In a
So,
graph? Does it need to be a graph database all the time, or it depends?
oh yeah, you want it in a graph database. I see a lot of wild things like here's ontology, and I'm not going to say Databricks, but here's ontology in a database. I've seen architectures recently, saw one that I was like, what is that? It was just a rigid structure that was like a table is a class, a column is a property, and a row is a relation. Like you see all of these, like, how do I cram this into a relational database? My question would be, why do you need to, do you want to store the ontological structure in a relational database? Are you trying to transpose and represent your relational database as RDF? Like, why? So I think really what's going to be interesting are the new sort of innovation around integration between relational stores, right? And ontologies. It's not about cramming one shape into the other, but how do we build an elegant interoperability layer between the two systems? And, the thing that I'm drawn to most of all are these sort of reference architectures right now.
That's really cool. I will link some of the blogs that you have written on this piece, because I read through these pieces specifically. Is there anything you wanted to cover that we did not cover?
Yeah, I think like what I'm seeing is there's this sort of misunderstanding about ontologies. Either they're too academic or that they're overly complex for the job. And I think we need a reset on that. There's no gatekeeping. The knowledge is, for example, I openly share the knowledge about this where you can learn about these things. But learning takes time. And if you are wanting to upskill or to learn these new skills and start to play around with these types of structures, there are fabulous resources, but no one's going to spoon feed it to you. It's really like a different type of approach. And to really understand, this is separate and apart from building a database. This is different logic. It's absolutely different logic.
Do you know about any like GitHub repo or something like someone can go?
There's so many. There's a really fun repo that just has a great collection of ontologies called Semantic Awesomeness. It's been around well before this LLM craze, and it just has like a running collection. God, it probably dates back definitely before 2016 or something like that, maybe earlier. So that exists. Now, the other thing for ontologies, because the W3C governs RDF and RDFS, it's openly available on the web. Just look up W3C ontologies or pick a domain or poison. There's the link to open data .net, which has like an interactive sort of stream of ontologies and different ontologies and how these linked data elements are talking to each other across the web. Like, this is not new, you know? Schema.org, for example, from Google is an ontology. So you have these representations. It's been embedded in a lot of the training data. So it's part of the discovery is seeing what ontologies do at scale on the web. There's industry standard ontologies that, you know, drive sort of gene discovery. You know, lots. There's, you know, choose your poison. Steve Hedden from Top Quadrant, he has a great graph of graphs, and it is literally a graph database of ontologies and taxonomies that are openly available on the web. I think he's at over 2,000 at this point.
Oh, really?
Yeah, like people don't realize like this is a thriving ecosystem. It's not new, wasn't invented yesterday. It's just now more people are coming into the fold, and you know the graph community, the RDF community welcomes it. Like, it's exciting, and it's just like we're not making up these rules. These are community driven rules because the standards and specs. Apache Jenna is the main graph database most people use. Obviously, that's open source. It's not controlled by anyone. This is about removing vendors. It's about data sovereignty at core. Like, you own your data, you own your model.
Makes sense. I think there's also a lot of noise because now it's in the buzz.
Yes.
And everyone can write with AI. So it's easy to write something about it. So I think listening to credible voices who have got experience and expertise in this field is really important. And I think you have been phenomenal with your content in Ontology. I really love reading them. You're also writing a book, right?
I am. So it's going to be published September, October, somewhere in that neighborhood. We haven't gotten the final. Yeah, it's really exciting. And it's Ontology pipeline, but I walk through building each of the stages towards increasing maturity towards a knowledge graph. And in the book, I present knowledge graph as an architecture with decisions. So
that's really cool. I'm waiting for it.
Hopefully it doesn't disappoint. I hope it doesn't disappoint. I just felt like it was really important to bring skills and to give people a resource. And like, after all, something core to my being and how I want to show up, especially, is that I'm a librarian and I'm all about reliable, unbiased information. So I try as much as I can to balance, the information I share. But then also I'm, also a teacher. And so that's where I combine those two things, because I just see this as such a need and doesn't need to be locked up. It can be something, but there is that point of, that a learner and, that relationship goes both ways. And so I want to make the information and the assets available, but then I also, I enjoy the dialogue that is from this, because I think there's a lot more room for innovation and the opportunities right there.
Absolutely. I think it has been a really, really engaging and really a great learning experience through a conversation, Jessica. So thank you very much for doing this podcast with me.
Thank you,
I'm
Sandi.
sure there'll be more to come from you. I will share some of the resources that you shared. I will research them myself as well, because I did not know half of them. So I'll look them up. I think this has been really great. Thank you very much for your time.
Thank you so much. This has been fun.